welcome. My name is Mahmoud Ismail and I'm a Technical Account Manager at AWS. And this session is Introduction to AWS Tools to help achieve operational excellence. So what is operational excellence? This is a very deep question, and depending on who you ask, you may get a different answer. There is one thing common to any organization striving for this, and that is operational excellence is built on embracing continuous improvement and ongoing problem solving. It's about exercising good habits and having mature systems in place that will help you reach operational excellence maturity. So, how do you go about achieving it? Here are some important aspects of operational excellence. Delivering great customer experience. It's very important to ensure the customer is at the heart of what you do. And from there, you work backwards to determine how you can improve your business processes, your procedures, your systems, and your tools. Focusing on what's important. It's not ideal to have your operation teams consuming their time with firefighting and less time on productive work. It would be more efficient if they focus their efforts on things that provide value back to the business. Adopting best practices. Establishing your own best practices for your own area of expertise or business results in running and operating your systems and your applications more efficiently and more effectively. And finally, the way you respond to issues when they do happen. It's critical to have the right mechanisms in place to help you move faster and operate at larger scales. And it's important that you're always finding ways to improve your response to events. The path to achieving operational excellence doesn't come without facing challenges along the way. There are many challenges that may arise on this path. And so, what are the common challenges we're seeing from our customers today? Once systems are designed, implemented, and tested, we come to what is arguably one of the biggest challenges in the life cycle of a system, and that is bringing it to life and sustaining it in operations. There are many challenges that can be discussed here, but working with thousands of customers over the years and listening to their challenges, there are a few that really stood out. These challenges revolve around visibility, automation, governance and control, and centralized operations. We'll look into each of these challenges in a bit more detail in upcoming slides. Overcoming these challenges boils down to three elements, all three being essential to operating the technology we build successfully. First, you need to have the right culture. Second, you need good processes. And third, you need great tools. All these elements go hand in hand, and you need all three to be addressed to help overcome these challenges and be on the path in achieving operational excellence in your organization. I'd like to focus this talk on tools and how tools can help solve the problems that these challenges present. The first challenge revolves around visibility. Does this sound familiar? What caused the service to go down? How do we correlate events and logs across our application? Why is our application performing so poorly? Can we further optimize performance? These questions arise because of a lack of visibility across the infrastructure and applications. I recall one time I was investigating an issue that occurred which happened in a production environment, and I was trying to find the root cause. When looking at the tools that I had at my disposal, I realized I couldn't diagnose the root cause, and that's because of a lack of visibility, which comes to not having all the facts or data presented to you. In a nutshell, we weren't measuring everything. Without the proper instrumentation and measurement in place, you operate in the dark and you begin to make assumptions. Another common problem is the need to correlate logs, metrics, and traces when your application spans multiple technologies and services. This makes it difficult to be able to debug your application at scale when these issues do arise, which ultimately leads to longer restoration times. Imagine needing to log into multiple tools and trying to make sense of all this data, each with varying formats that you need to decipher and correlate on your own. Tracking down the root cause and avenues for optimization becomes a problem. A rule of thumb here, and a very important thing for organizations, is to nurture a culture of measuring everything. This will put you in a better position to quickly identify when things break and understand the reasons why they broke and make sound judgments to mitigate or to better optimize. There are a rich set of tools that can help with these problems. I'd like to show you two core services at AWS that can help address these problems: AWS CloudWatch and X-Ray. As mentioned previously, monitoring will help you identify when things break. And so you need tools that can collect metrics and logs from across your infrastructure and applications. With CloudWatch, you can receive metrics from over 90 AWS services and also set up custom metrics specific to your application. And from there, you can create dashboards with customized views of the metrics you've collected. The more metrics you collect, the better, as this addresses the previous problem I discussed earlier regarding a lack of visibility. Once you feel you're monitoring the right things, you can go one step further and look into running playbooks as a response to metrics reaching the thresholds that you have configured. This reflects continuous improvement and maturity in your monitoring practices. CloudWatch allows you to centralize logs from the AWS services you're using and from your application. From there, you can use Logs Insights to interactively search and analyze your logs, helping you to dig deeper into any operational issues that you may experience. You can do things like tracking the number of errors that occur in your application logs and send notifications to your ops teams whenever the rate of errors exceeds a threshold that you've specified. Another cool feature is that you can stream these logs to another AWS service and third-party tools that you may be using in your infrastructure or your organization. So how is CloudWatch used? Let's say you're using CloudWatch in your account and you want to receive metrics and logs from your on-prem and cloud resources. The first step is to install CloudWatch Agent on them. These agents can send system-level metrics, performance-level metrics, custom application metrics, and you can also collect logs and send them off to CloudWatch. As mentioned before, you can configure notifications and set automated actions when these metrics reach the configured thresholds. You can choose to receive notifications via email or SMS for further troubleshooting, or you can incorporate automation through your runbooks to take certain actions. So monitoring helps identify when things are broken. But how can you dive deeper to understand why things broke or started performing poorly? This is where observability comes in. Your application is made up of underlying services, and so for transactional requests traversing it, you need the ability to collect data from these services and create dependency mappings that can help you investigate issues. There are tools that can help fulfill this requirement. At AWS, we have X-Ray. X-Ray can collect data from each underlying service and combines them into what we call traces, which is a collection of data points that makes up your application. X-Ray can create a service map and provide you with a view of connections between these services, presenting important metrics like latency and failure rates. Now, since the trace is capturing the end-to-end transaction, operations staff no longer need to log into individual services to troubleshoot or identify issues. You can just get the user-centric view from a single location. Ultimately, you can use this trace to follow the path of an individual request as it passes through each service in your application to help you pinpoint issues and areas for optimization. We've spoken to customers who've said that mean time to resolution used to take roughly half a day. But with the right observability tools in place, they were able to bring this down to hours or even minutes. To put this in a visual, let's say you have an application that's made up of three underlying services: API Gateway, AWS Lambda for serverless compute, and DynamoDB as a NoSQL database. So once you've instrumented your application to use X-Ray SDK, it will start emitting data that X-Ray collects and records them as trace data. From there, it aggregates into a service map which you can view to see how your application is performing end to end. If you'd like to learn more, we have another session on monitoring and observability. Please do check it out. The second challenge we see customers facing revolves around automation. So why is automation so important? Automation is about transforming IT operations. It's about powering the execution of tasks and process workflows to automatically provision resources and automate manual tasks. So what are the common problems we're seeing from customers today? Scaling becomes a problem. Having to manually create and add pieces to your environment doesn't scale. And you can introduce inconsistencies due to human error. and we all know that human errors do happen. I'm sure that every single one of us has experienced this in their professional career at some stage. Another problem is that manual tasks has an effect on efficiency and agility. Having automation frees the organization from mundane tasks and allows them to focus on what's really important, things like innovation and improving customer experience. And so, how can you tackle these problems? For automating your environment, the common practice nowadays is to define your infrastructure in configuration files, also known as infrastructure as code. There are a number of tools that exist for this, but the main idea is to have something that can create and build your resources in an automated fashion and ensure that this is repeatable and reusable across all of your environments. You also need to think about having your operation procedures as code and automate the execution by triggering them in response to events. By performing operations as code, you limit human error and you enable consistent responses to events. Being able to automate provisioning of your infrastructure and automating all your repeatable tasks will drive you closer to operational excellence. And again, there are different tools that can help achieve this. With AWS, we have a range of cloud-native tools to help with automation, which I'll discuss in the upcoming slides. AWS CloudFormation is a service used for provisioning AWS resources in your environment. You can create over 500 different types of resources across multiple accounts and multiple regions. You start off by coding your infrastructure in a configuration file, YAML or JSON format. You upload this to a CloudFormation service, and from there you can create your CloudFormation stack. This stack is what's used to create your resources. AWS CloudFormation provisions resources in a repeatable fashion, allowing you to build and rebuild your infrastructure without having to perform manual actions or write custom scripts. And this addresses the lack of automation challenge that I've discussed earlier. Using CloudFormation allows you to treat your infrastructure as code, and so you can author with any code editor. You can check it into a version control system, and you can review this with your team before you decide to deploy this into the appropriate environment. For automating manual tasks, AWS Systems Manager has two core services. The first one is Systems Manager Run Command, which is great for automating common admin tasks, targeting a fleet of instances that may include EC2, on-prem servers, and virtual machines. You can choose to run an ad hoc command or execute as part of a script and a part of a deployment pipeline. Some use cases include installing agents or apps on your fleet, and third-party management scripts such as PowerShell or configuration management tools. The other service is Systems Manager Automation. With this service, you can build automation runbooks and workflows. You can perform complex automated processes by branching based on the results of the previous steps, and also monitor and receive notifications on the progress. A use case here that operation teams will find attractive is the simplification of complex tasks. For example, creating golden images, operational runbooks to recover unreachable resources in your environment, or could be any response that makes sense to you in responding to events when they happen. Automated deployments are the backbone of a strong DevOps environment. You want to ensure you can run automated deployments to remove bottlenecks and enable your teams to innovate and rapidly deliver new features for customers. As important as they are, automated deployments can't solve everything on its own, but in fact are part of a bigger picture. They should be part of a workflow that starts when a developer commits code and ends when that change is successfully running in production. Developer Tools provides a comprehensive set of tools used to build out your CI/CD pipeline and can accelerate your software development and release cycles. These services can host your code and software packages. It can build out your packages, it could compile code, build out your container images, you can integrate with third-party software for testing, and deploy into your environments. As an example, Amazon at one stage discovered it was taking an average of 16 days from code check-in to being deployed in production. It also found that operations personnel carried out significant manual work, including emailing and ticketing. In other words, developers spent most of their time waiting, and that was the problem Amazon wanted to solve. How do we automate the production line to avoid developers from having to wait? The adoption of such tools like AWS developer tools becomes very critical so that you can drive consistency, standardization, and simplification of your release processes. The third challenge we see customers facing revolves around governance and control. There are a few key areas we could go into, but I'd like to focus on a few things our customers ask us. In particular, the ability to manage resources, auditing, and compliance. Cost is another important aspect of governance, and if you'd like to learn more, do check out the session, How to Succeed at Cost Optimization on AWS. So what are the common problems that customers face? Typically, we see customers, as they grow, face demarcation and isolation challenges across their business. That is, governance at scale becomes hard. How do you control access and permissions to resources for a particular team? How do you track changes across your resources and still ensure you're following security and audit requirements? Solutions for this revolves around the need to have automated workflows for setting up resource isolation, policy automation and enforcement, identity federation, and so on. You'll also need to ensure you're continuously monitoring and recording your configuration changes across your resources, and that you're continuously auditing and assessing the overall compliance of your resource configurations against your organization's policies and guidelines. With AWS, there are tools that can help address this challenge, which we'll go through in the following slides. Let's look further into AWS organizations. It's important to note that you can organize and isolate your resources using AWS accounts. Think of it as a way of putting resources in groups that you can apply policies against. And so, organizations helps you centrally govern and manage your accounts in your cloud environment. There are many advantages of using multiple accounts in your environment. And so, I encourage you to look at best practice multi-account strategies and self-service architectures that can help you address your needs. Using organizations, you can quickly scale by creating new accounts, which you can then start allocating resources under it. From there, you can group accounts into what we call organization units. All these can be managed by one master account, which becomes the root for all other accounts within your organization. And from there, you can apply security control policies across your organization, which helps you to ensure your accounts stay within your organization's access control guidelines. Next service to help with audit and compliance is AWS Config, which enables you to assess, audit, and evaluate configurations of your resources. It continually monitors the configuration of your AWS resources. It compares current configurations against configuration standards you have set and tracks any changes that's been made to your resources. These configuration standards are contained in rules, and basically, AWS Config checks configurations against these rules and alerts if they're non-compliant. You can optionally send out notifications and trigger automated workflows. An example here could be setting up rules that flag and respond to critical resource changes. Let's say you're part of a security operations team and you want to monitor the status of an S3 bucket, whether it's publicly open or not. You can set up custom rules to trigger an automated workflow if that S3 bucket becomes publicly accessible, and this workflow can reconfigure the S3 bucket to become private. AWS CloudTrail is a service that can help increase visibility by recording all activity in your environment. You can identify which users are responsible for certain actions and the source from which these calls were made. This makes security and troubleshooting much easier for ops teams. CloudTrail records all activities as events and can be kept as event logs in a secure S3 bucket that you can query for further analysis and insights. CloudTrail allows you to track and respond to specific events that you'd like to monitor. For example, you can configure when CloudTrail logs an activity that makes an S3 bucket public, a CloudWatch rule triggers a workflow that adds a specific policy to that S3 bucket. So, as you can see, CloudTrail makes it easier to ensure compliance with internal policies and standards by providing a history of activity in your AWS accounts. The fourth challenge we see revolves around centralized operations. This is a deep topic, but I'd like to focus on operations management, patch management, and backups, as they are important in every organization. A common problem we see is a lack of centralized monitoring of operational issues that arise. Traditionally, different systems have their own way of servicing issues, meaning you'd have to log on to separate tools to monitor their respective issues, which makes it much more difficult for ops teams. From a patching and backups perspective, customers often resort to scripts and ad hoc processes when performing these tasks, which can lead to errors and missing coverage across their environments. And so the way to address these problems is by having a centralized view for operational issues and an automated workflow for patching your instances and backing up your resources. With AWS, there are tools that can help with this, which I'll go into further detail in the following slides. In regards to operations management, AWS Systems Manager offers a service called Ops Center. Ops Center provides a single pane for ops teams to view operational issues in their environment. Ops Center aggregates different work items across many services and provides you all the relevant data to help you monitor issues and resolve them quickly. You can provide System Manager runbooks to help you remediate issues once they've been identified. If you have an existing ITSM system already in use, you can integrate Ops Center directly, and so you can maintain manual lifecycle workflows in your current ITSM and use Ops Center for investigation and remediation. Here are some examples of some items created in Ops Center. Security issues, such as alerts from AWS Security Hub. Performance issues, such as throttling events for your database or degraded volume performance. Or failures, such as Amazon EC2 failing to launch an instance. Patch Manager automates the process of patching managed instances with security updates. The primary focus of Patch Manager is installing operating system security-related updates to your fleet of instances, which include EC2 instances, on-premises servers, and virtual machines. For each operating system, you define a patch baseline, which defines which patches are approved for installation on your fleet. You can set up rules for auto-approving patches. For example, you can auto-approve critical updates once they are available. You can also schedule automated patching during maintenance windows, or you can patch manually at any given time. As a common practice, you can have a workflow that's triggered by a scheduled CloudWatch event, which invokes an automation runbook that patches all your instances in your fleet. You can break up your instances into different patch groups, with each group being patched by a specific patch baseline that's specific to that operating system. This could be run at scheduled maintenance window, and after completion, you can check for compliance and send notifications accordingly. If you'd like to learn more, do check out the session Automating Patch Management and Compliance using AWS Systems Manager. AWS Backup is a fully managed backup service that makes it easy to centralize and automate the backing of data across your AWS resources. You can create backup policies and plans, and then you can use these plans to define your backup requirements, things like frequency, retention, and expiration. And you do all of this in a policy-based way. For each particular supported service, you can restore from different recovery points, and each recovery process is unique for each supported resource type. You can view the status of these restores from a central view. Without AWS Backup, you'd have to perform backup operations per service and per account, which increases complexity and makes reporting very difficult. And so this service provides a central way to back up your resources and makes reporting easier. To recap, we've gone through some common tools that help address some key challenges we're seeing from our customers. By no means is this an exhaustive list, as AWS has a rich set of tools to help customers address their challenges based on their use cases. Along with AWS tools, we also have an exhaustive list of partners with tools and solutions that can also help address these challenges. The important thing is to recognize that tools are an integral piece on your journey to operational excellence. So, some key takeaways from this session. Achieving operational excellence revolves around three different aspects: culture, process, and tools. All three require attention and go hand in hand. Focus on delivering a great customer experience and work backwards from there to improve how you function as a business and it's important to understand your challenges and what problems your organization is facing in order to determine the right tool for the right job. From a tools perspective, it's important to adopt a culture of measuring everything and automating what you can. To get started on your journey and get introduced to the AWS services and tools that will help you transform your business, you can keep learning beyond this event with AWS training and certification. For more information, visit aws.training/enterprise and see what resources are available to you to help you achieve your goals. Operational excellence is an ongoing journey. Remember, it's all about improving your systems and your habits and ensuring you have the right tools to help support you. Thank you for watching. Please do take the time to fill out our survey and let us know what you think. Hope you have a great summit.